Question 1. Please make sure that you are keeping track of your score and then keep track. Of course, you're going to get 9 when you're done, hopefully. Right, at time t, a particle moving in the xy plane is at position x of t, y of t, where x of t and y of t are not explicitly given. For t greater than or equal to 0, we're given a formula for dx dt, and we're given a formula for dy dt. We also know that at time t equals 0, x of 0 equals 0, and y of 0 is equal to -4. So part A, find the speed of the particle at time t equals 3, and then find the acceleration vector of the particle at time t equals 3. Okay, we know the formula for speed is the square root of x prime of 3 squared plus y prime of 3 squared. And so we'll just, let's see, we'll get x prime of 3, if I plug in 3 here, I'll get 13 squared. And if I plug this in, I'll get sine of 9 squared. And then we'll let our calculator do the work for that one. We should end up getting 3.006, I believe. And so that was our speed. And then to get our acceleration vector, acceleration is the derivative of this. And since we're finding it at t equals 3, we're basically just going to take the second derivative of at 3, and then we'll take the second derivative of y at 3. And since we are finding it at a certain value, we can use the Math 8 feature of our calculator. And when we do that, that should give us the vector 4, -5.466. Alrighty, and so that was worth, this part of the problem was worth 2 points. If you got the speed, that was worth a point. And then if you got the acceleration vector, that was worth a point. All right, part B, find the slope of the line tangent to the path of the particle at time t equals 3. All right, it's asking me for the slope of the tangent line, which I know is going to be dy dx. So to find dy dx, remember that's just going to be dy dt over dx dt. The derivative of, and actually, again, we don't have to do the derivative by hand because dy dt is just going to be the derivative, so it's going to be the sine of 9 over dx dt is going to be 4 times 3 plus 1, which would be 13. So if we do sine of 9 divided by 13, hopefully we come up with 0.031. One thing that I'm going to say on this one is please make sure your calculator is in radians at this point in time. So we should get 0.031. That was worth simply just 1 point. Okay, part C, find the position of the particle at time t equals 3. Well, we know if we're at a derivative, that's a velocity, and we want to get to position, we're going to take the integral, especially when we get to this part right here. This is going to be a harder, the sine of t squared is going to be a harder one to take the integral of. Since we're looking for at time equals 3, though, we can actually use the fundamental theorem of calculus, which I think we used on a problem last week. So to get the position, what I'm going to do is I'm going to start at 0 and 3. And I'm going to take, if I take the integral of dx dt, the integral of dx dt is just going to be x, and then I know I'm going to have to do x of 3 minus x of 0. And so then from here, I can actually calculate the integral from 0 to 3 of dx dt by using the Math 9 feature of the calculator. And when I do that, that should equal 21. And then that's going to equal x of 3 minus x of 0. And they did tell us that x of 0 at 0 is 0. So then basically we get that x of 3 is equal to 21. All right, and then doing that same thing for the y value, we're going to go 0 to 3 dy dt. That will equal y of 3 minus y of 0. Again, we'll use the Math 9 feature on the left side. And if I use the Math 9 feature, I believe I'll get, let's see here, I should get, I just have a final answer here. That's what I'm trying to think of what I'm going to get when I do this. I'm going to get, if I subtract 4 from 9, I think I get 1.226, I'm pretty sure. And then we're going to get y of 3 minus y of 0. And y of 0 we know is -4. So that's going to turn to plus. So to get y of 3 by itself, I'm going to subtract 4. and I know that that is not the right answer. There's a number there, you can figure it out. When I do that, I should end up getting y of 3 is equal to negative 3.226. So when it asks for the position of the particle, the position is at is at 21 comma negative 3.226. All right. This was worth 4 points. Whew, all right. You're going to get 1 point on this for having an integral set up. You're going to get 1 point for getting the 21, and then you're going to get 1 point for the integral set up for y, and then you're going to get 1 point for the actual y coordinate. So that part was worth 4 whopping points. Okay, part D, find the total distance traveled by the particle over the interval from 0 to 3. We have a formula for that. The distance traveled is actually just an arc length. So if you'll remember, we're going to do dx dt squared plus dy dt squared. So it's going to be the integral from 0 to 3 of 4t plus 1 squared plus sine of t squared, and I would just leave it just like that as I type it in my calculator. And once again, we can use the Math 9 feature of our calculator. And when we do that, we should get 21.091. Right, and that part of the problem was worth 2 points. We're going to get 1 point for our integral setup, and then we're going to get 1 point for our final answer. So hopefully you scored well on that question.